All right. Hi, everyone. Welcome back to Advent of Code. Sorry, this is a few days late. Was not feeling too well the past couple days, so decided to take a little break from recording, but we're back. So day 5 is relatively straightforward in terms of the actual solution, but again, because we're working on C++, the input processing got a little bit annoying, but that's all right. So reading through this, we can see we have this food production problem. And so essentially what happens is we're given these seed values, and we have 4 in the test input, but we'll have significantly more in the real input. And essentially the goal is to convert each seed value to a final location value, right? And so these numbers here, the 50, the 98, and the 2, the 52, the 50, and the 48, these are kind of like functions, and they'll tell you how to map from the seed domain to the soil domain, and then how to map from the soil domain to the fertilizer domain, and so on. So you can see this would be, you can hard code this, but we're going to go for something a little bit more elegant, which is essentially we'll keep an array, or a vector, I should say, of all the maps, and then we can just write some generalizable function to apply a map. And so we'll see what that looks like. But first, let's understand what the functions themselves do, or how they operate. So basically, this is a good depiction down here. So notice that recall that the first line is given in order of 58, 98, and 2. So 50 tells you where the soil range starts, and 98 tells you where the seed range starts, and 2 tells you the length of the range. So what that means essentially is we can represent, so let's say, we want to abstract this a little bit. Let's say we're trying to map from seed to soil. Well, we could call soil the destination and seed the source. So in general, the input is given in terms, or given by the destination start, the source start, and then the range length, right? And so what that means is that basically starting at soil number 50, that maps directly to seed number 98, and then you do that for 2 numbers. So it's inclusive on the lower end and exclusive on the upper end, like essentially most ranges happen when we're programming. So we can get right into the code here. I just have to create a new day real quick. So let me run that script, day 5. And then while we're at it, let me actually grab the test input as well, just so we have that. And yeah, like I said, the actual application of or solution, I suppose, is relatively straightforward. It's just that the input processing gets a little bit tedious. So let's kind of put this to the side, and then we'll pull out our part 1. And we'll look at how we can implement this. So the first thing that I want to change is that because I'm coming into this having already solved this problem, I know that the answer is going to be bigger than the C++ memory limit for an int. So we're going to have to work with doubles here, which is fine. That's a small thing we can get out of the way at the beginning. And let me zoom in a little bit just so it's easier to see. So the first thing we want to do is we want to have a way to store our seeds, right? And clearly we can just use a one-dimensional vector here, and we'll keep them as doubles. Again, we're just going to keep everything as doubles for the sake of simplicity. Which means we should also cast our integer, or our answer, to an integer. Now, the second slightly more complicated thing that we need to store are these maps. And we want to store each, or the way that I did it was I wanted to store each individual map as a vector. And then within this seed to soil vector, I would have, in this case, two other vectors, one with 50, 98, and 2, and one 50, 98, and 2, and one with 52, 50, and 48. And then I want one larger vector to store each map vector. So essentially we're going to be working with a 3-dimensional vector here. however, so yeah, a three-dimensional vector here. However, the third dimension um, is of finite length, or not finite, but definite length, right? So of course, all of the vectors are of finite length, but what I mean is that this third dimension will always have three elements, and so we can use that to our advantage further down into the solution. But for now, let's just initialize a three-dimensional vector to store doubles, and we will call this maps. I think I need one more angle brace there. There we go. Perfect. And I'm just going to leave a comment for ourselves depicting the structure of this. So remember, or I guess recall that we have the destination, the source, and the length given in that order. So that's probably how we're going to want to store these. And then, you know, we'll do that for every line, or for every set of destination sources and lengths that are given in a single map. I guess I have one too many there. But no, this is only two-dimensional, that's why. Okay. Yeah, my fault. Wonderful. Okay, so now we can move on and we'll start parsing the input. So like always, we're going to iterate over the lines in the input. And that's seemed to be the easiest way to do it. So the first thing that we'll observe is if I is equal to 0, so if we're on the first line, then we'll always have the seeds. We'll always be given the seeds. And so we can use kind of the approach we've been using in pretty much all the other days where we have input like this. And basically start, so we'll start after this space, and then every time we encounter a digit, we'll modify some current, or some variable by that digit, and then every time we encounter a space, we will append, I guess, this previous digit to our storage. So I'll initialize a current seed at 0, and then we'll start iterating from index 7, because that's where this first number starts in both the test and the real input. And we want j to be bounded by the length of the current line, and we will increment it by 1. Great. And then, so again, kind of the general process we've been using is if we check if the current character is a digit, and if so, we want to modify the current seed value by the digit which we encountered, by first casting it to an integer and then applying this kind of this formula to obtain a current seed value. And we've seen this in some days before, so I'm going to skip the explanation. And otherwise, if the input, or excuse me, if the current character is a space, then we want to push the current seed value into our seeds vector, excuse me, curseed, not seeds, and we want to reset the current seed value and then continue. And then finally, we need to handle the case where we are at the last character, because there's no trailing space for the line. And in this case, we just want to push the current seed value into the seeds vector. Wonderful. Okay. The next case is that if I is equal to 1, and clearly we can see that we want to just ignore that. It's an empty line. So else if I is equal to 1, we can just continue. And then else. Okay, so now we've encountered our first map. And like I said before, if we were to hard code this, we would want to keep track of like which map this is. But actually, because we're developing a more general solution, it doesn't matter that this is the seed to soil map. It just matters that it's the first map. And so I'm going to initialize a vector of doubles called current line. And what current line is going to store is the destination, the source, and the length. So exactly like this. And so current line is what we will append, or what we will push into our maps vector eventually. And I guess I don't I guess I don't need this here. We can just do the declaration. So we'll initialize a current value again, and we're just gonna, it's the same process that we use for parsing the seeds. So actually, I'll just copy this and then modify what we need to. So of course, instead of current seed, we want to modify current value. And then of course, instead of starting at, well, no, I suppose we can still start at 0. And it looks like, yes, so if it's a space, we will push, instead of pushing into seeds though, we want to push into current line, and then reset current line. Wonderful. And then we also should be storing a current map somewhere. And so basically, rather than, so we do need another case here. So if we can either be at 0, 1, or we can be like on a line that has valuable information, or we can be on a line that just has these titles. And if we're on the line that has the titles, essentially those will function like the spaces do when we're parsing a line, basically telling us that, okay, it's time to now append the previous map to our maps array, or maps vector. So if input I dot size is equal to 0, which means we're on a new line here actually. So I suppose rather than using the titles themselves, we can use the new lines. So if the size of a line that we encounter is 0, then we want to push back the current map, which I believe I forgot to initialize. So let me do that real quick. And we want to reset the current map, and then we want to continue. So we will initialize the current map actually outside of even the outermost for loop, because we can have so this for loop is iterating across the lines, but a single map can clearly go for multiple lines. And so if we initialize this inside this for loop, then we would be resetting it, and therefore like losing information basically. Great. Okay. So everything looks good there. The next thing that we need to do is, yes, so we need to push our current map, or excuse me, our current line into our current map. And then if we have reached the end of the input, we want to push the final map onto our maps vector. So we'll maps.pushback current map. Great. Okay. So that's that for parsing the input. Now we can actually solve the problem. And in order to do that, we're going to use this observation that we don't need to we don't need to actually compute really, or we don't need to like brute force anything. We can just use a simple formula. So you can see here, like, let's say we're looking at seed number 98, and we need to map it to 50. Well, the way we're going to do that is by adding the difference of 98 and 50 to our seed, if that makes sense. So to be a little bit more, so to be a little clearer about that, like, let's say we're looking at seed 98. We're going to, if seed 98 is within the range that we need to convert, then we're going to add onto 98. We're going to add the difference between 98 and 50, or excuse me, 50 and 98, right? So in this case, it would be negative 48, and that's exactly what we need to do, because this is just a linear, like, bijection, essentially. And that's the easiest way to do it. So let me initialize another vector of doubles that will be our like final location numbers. And again, the location number is kind of an arbitrary thing. It's just, that's what they tell us the final layer is called. So that's what I'm calling it, but you could just call it final layer or whatever if this was more of a general problem. So for seed so we're basically gonna convert one seed at a time rather than doing a bunch of seeds in parallel. I think they're equally fast because it's the same it's the same time complexity. But I haven't tried the other way, so it might be something to experiment with. But anyways, we'll start by iterating through the maps. And basically, we're going to treat each map as a function, as I said before. And we will initialize another vector of doubles, two-dimensional vector of doubles, called the current map, just so we don't have to keep typing maps I. And let's see, it looks like I messed something up here. Expected an identifier. Okay, I'll fix that in a moment. But for now, for int j equals 0, we're going to iterate through each line in the current map and basically check whether or not we need to perform any conversion. And so the current range is basically points to the current line, right? So cur range equals cur map j. And again, so now we're looking at, say, like just line 4, for example, or just line 5, depending on the value of I or j. And then basically if seed is greater than or equal to the current range 1, because remember the second value is the source start, and seed is less than cur range 1 plus cur range 2. So this is like basically checking that we're in the range that would need to be converted or mapped. And I'm calling this seed, but like, for example, when we get to this map, it won't be a seed anymore, it will be soil. But I'm just calling it seed. So we'll have a difference value called cur range 0 minus cur range 1. And again, we can just add that onto the seed and then continue and break. So the reason we have to break here is because we'll see that, like, for example, in the fertilizer to water map, because we have multiple ranges, it's actually possible that, like, if we don't break, after converting a fertilizer to a water here, we would actually then perform another conversion. But and I don't know if it says explicitly in the problem, but it's a fair assumption that we only want to perform like one function application per map, if that makes sense. So yeah, why is this is being strange? For int I equals 0, I is less than maps.size, I plus plus. I'm confused. What's wrong here? Am I missing a curly bracket or something? Let's see. Expected an identifier. Okay, maybe I'll just rely on my my AI to fix this for me. Missing identifier in the second for loop. What's the issue? I've added int. Oh, I simply forgot my variable declaration. To name my variable. Okay, wonderful. That was a stupid mistake. Anyways, we will push back then so once we've iterated through all the maps and applied their functions, we will push the final location number into the location nums, and then we just want to return the minimum of that. So I'm going to set answer equal to just some very large number, and then for location number of location nums, ants is just equal to the minimum of the current ants and the location number. And then if we go ahead and compile this, get rid of the test input. I don't know why we're still crun. I have to cd day 5 crun part 1, and then run it on the test input. We get 22, which I can already tell is wrong. And so let me just do a quick little look through and make sure everything is okay here. Let's see, cur seed, cur value. I'm gonna take a look and I'll be right back. Okay, sorry about that. Pretty rudimentary mistake. So basically, when you are reading through the test input, I think I mentioned this, but I didn't actually code it. When we encounter these like textual lines or the titles of the maps, because we're not hard coding our solution, these titles don't really actually matter that much. And so basically, we just want to continue past those lines when we're parsing the input. So essentially, we did this first check to make sure that, or basically if the size of the input is 0, so essentially if we're at one of these new lines, we need to like basically push the map that we just created into our maps vector, and then reset it and continue. But the one case that I missed or didn't write down was that on the next line, you know, when we encounter these titles, we also want to continue because they don't matter. So we can see if we recompile and rerun, we get 35, which is correct for the test input. And then let me run it on my real input as well, just to make sure. Okay, maybe I need one more zero because, or I'll add a few more zeros. So let me recompile and run it on the real input. There we go. So that's a pretty big number, 570757558. 570757558. Wonderful. Okay. So sorry about those hiccups. I know this video is going on kind of long, so I'll try to speed through part 2. If you want a really, really good solution, this is where my solution came from, please check out Jonathan Paulson on YouTube. He also does the Advent of Code challenges. He does them live and he does them in Python, or like he records it, you know, as he's solving it during the real competition. It's pretty cool. He's very, I don't know him personally, but very, very intelligent guy, clearly. And so this solution is inspired by his work. So thanks to him for publicizing that. But basically, if we read through the problem statement, so now it isn't much different, but instead of each seed number representing just a single seed, we now want to interpret these two numbers as a range of seeds. So 79 tells us where the range starts and 14 tells us how long the range is. So we have 79 to 93, and we want to check all of those seed numbers. And so I think probably if you ran those 14 seed numbers, so I guess in the real input you only have, or in the test input you only have 27 seed numbers that you'd have to check, but in the real input, if we just take a look, like you have, you know, on the order of billions of seeds to check, which you cannot do by brute force, so we need to be a little smarter. And the idea here is that you want to segment your range, or each seed range, into 3 parts. So the first part is like, maybe I'll pull up like a annotation thing here. Okay, so essentially, like let's say you have your source range, right? So source and destination. And I don't know, let's say this is like X, and so it goes like X to Y. And then your destination goes like X1 to Y1, right? So basically what you're interested in is, I should probably have drawn this a little better, but like basically if we imagine that there's like a number line here, you're interested in like this area of the number line, right? Because it's only numbers between X1 and Y that you actually need to convert. Right? So this only depicts like one case. There's 2 other ones where like there is no overlap, right? Where like destination is all the way over here, and source is like all the way over here. But we can handle that. So the key here is that we want like this range. So in my code, I called the stuff that's to the left, so that like is only X, would be like before, and then the part that we're interested in, I should probably just type this. The part that we're interested in is enter, and then here is after. Okay, and so only enter is the only range that we need to convert. Great. So let me close out of this and then pull up the code again. So we're going to use the same input processing that we used for our for part 1, and let's see. So I'm just gonna paste this, and then really the biggest difference is that, just for ease, this is what Jonathan Paulson did, and so this is what I'm doing as well. It makes it a lot easier to create a class definition of a map, because then you can basically store. It makes the solution quite a bit easier. So we will have our ranges, but I call these lines in part 2, just to be like a little more precise. Well, I guess you could argue that it's less precise, but basically a line tells you like, it's like this, right? It's a collection of ranges. Great. Okay. So, and then we'll write our constructor. So we'll take in a vector, a two-dimensional vector, again, of doubles, called processed lines, and we'll just pass into there the process lines that we did from part 1, basically. And then we also want a public method which is going to return a stack, which is basically similar to a vector, but it has like pop and push operations, which is nice. And we're going to call this function map. It's slightly confusing, but basically this, or maybe I should call it like apply map. And it will accept a stack of vectors, and each vector is a range. And so let's see, I think I need to include stack up here. That's why it's giving me an error. Include stack. Great. And then, so within this code, what we're going to want to do is basically perform the operation that I just drew. So we'll initialize like a return value, basically, called map ranges, which will just store like the ranges after performing the mapping operation or applying the function. And we're going to iterate through the lines in this map, because remember, we're working within the class definition. And we'll have a destination, so line 0, we'll have a source, which will be line 1, and then a length, which will be line 2. By the way, so in Python, like, you could just write like def source length equals line. If there's anything like that in C++, please let me know, because syntax like this is kind of annoying. But we'll also initialize a source end variable, which is just equal to the source plus the length of the range. And then we'll initialize a stack of vectors, again, and each vector stores a double, or stores some doubles, and this is going to be new ranges. And what we're going to do is basically, while the ranges variable is not empty, we're going to like take off the pop, essentially, the current range, which is equal to ranges.top, and then we're going to pop that off of ranges, and then we are going to extract the start and the end, and then we want to initialize those before, after, and or before, enter, and after. So before, we'll start at start, and it will go to the minimum of end and source. Let's see, enter is going to go from the max of start and source to the min of source end and end. And by the way, like the max and min operations here allow us to avoid just a bunch of if statements, because as I said when I was drawing it, there are more cases than just that one that I drew, but the max and min operations here will handle that, which is very nice. And then so basically, if the second element in before is greater than the first element, then we want to push before onto our new ranges. And then what am I missing here? Why is this cur range? Oh, I need another R. There we go. And then I'm just going to copy this 2 more times, and we'll replace before with enter and after in both cases. So enter and after, and then but because inter, remember we have to perform the mapping, we have to do something slightly different. And so here we'll be pushing inter 0 minus source plus dest, and then inter 1 minus source plus dest. So this is like the same thing, the same operation that we performed in part 1. And then after, there we go, and new ranges dot push after. Wonderful. And once we've done that, we can set ranges equal to new ranges, and we can append, or I should say push every range within the new ranges onto our mapped ranges, which is our return value. And then we'll pop it off, of course. And then finally, we can return mapped ranges. Mapped ranges. And I believe this needs to be actually in here. Okay. So let's just do a quick review. So essentially what we did was we're accepting like a stack of vectors, and each vector is a range that it comes in the form of like start end. And we want to map these start and ends to different start and ends, but we only need to do that if the inter case is true. And so let's see, expected a semicolon, probably need one there. Okay. And then, so now what we're going to do is we'll extract those seed pairs. So we have our vector of seeds, but recall that now we're interpreting them as pairs. So for int I equals 0, I less than seeds dot size I plus plus. Well, actually we want to iterate by 2, which means we should go to seeds dot size minus 1. And then we're going to seed pairs dot push back seeds I and seeds I plus 1. Great. And then we will, I need a semicolon. We will initialize a vector of that class map called map objects that we just wrote. And then we'll basically just construct maps out of all the maps that we have already processed. So map cur map, and then we'll pass in maps I, and then we will map objects dot push back cur map. Great. And then finally, we can go ahead and apply our map functions. So we will initialize a vector once again of doubles called location intervals, and then we are going to iterate over the seed pairs, dot pairs dot size, and then I plus plus, and then we're gonna have our range start, which is just equal to seed pairs I 0 and range length double range length equal to seed pairs I at 1. And then we are going to have our stack of vectors, and this is what we'll be passing into the map function for each map. I'm just going to call it R, and then into R we are going to push range start plus range length. Wonderful. And then for map, let's call it map of maps. This is why it's good that I changed my function name to apply map, because otherwise we would just keep writing the word map. And then so once we've gone through all the maps, we can look for the minimum location interval. So min interval start is equal to just some very large number. And then we will initialize a copy of R called R copy, because there's not really you can't do a for loop over a stack or traverse over a stack in that way. So we need to use like the popping syntax, but we don't want to actually pop stuff off of R because that could mess up future computations. So we make a copy of it, and then we extract the current interval by popping from R copy. So dot rcopy dot pop, and then we want to set min interval start to the min of the current min interval start and the current and the bottom value of the current interval. Great. And then after the while loop, we can just push the min interval start onto the location intervals. And then the very last thing is just to get our answer by getting the minimum of the location intervals. So for double location of location intervals, we can say ants equals the min of ants and location. Great, and I hope that this works in the first try. If not, though, that's okay. We get 46, and the reason we have decimal places there is because I forgot to cast the answer to an integer. Looks like 46 is correct, and then let's just run it on the rail input real quick. Oh, well, I didn't recompile, but that's fine. So we have 31161857. So 31161857. Wonderful. All right, I am sorry about the longer video, but I do hope it was helpful. Once again, huge thanks to Jonathan Paulson for his great content. Yeah, I will see you guys tomorrow.